So for the final exam, we have chapter 2, we have chapter 3, and we have chapter 4, 4.1 through 4.9. Not, I don't remember, 4.7 or something in there. So chapter 2 deals with limits, chapter 3 with derivatives, and chapter 4 with applications of differentiation. So remember here we had those graphs with a table. We had Newton's method and optimization. So graphs, Newton, optimization. Here we had all sorts of limits, and now you feel free to use L'Hopital's rule. Although it's in chapter 4, who cares? You can use it now on everything. Here derivatives, basically all the rules. Here we also talked about related rates. Logarithmic differentiation, implicit differentiation, differentials, and approximations. So what would you like to start with? Oh, and I had one of your colleagues asked about this problem. Do you want to do this? Limit as x approaches 0 from the right from cosine to raised to 1 over x squared to find this limit.
Sure.
Okay, so let's do that first, and then we'll come back. So we had the limit as x approaches 0 from the right from cosine x to 1 over x squared. So first you have to identify what it is. So what is it? What is the initial assessment of this? Anyone?
Is it 1 to infinity?
Yes, it is 1 to infinity. Because it is 1 to infinity, we do have to show the following steps. In step number 1, we have to name the function. Why on earth will I need to name the function? It's because in step 2, I apply to both sides. If you want, this is an equation. In step 2, I apply natural log. That's why I have to start by showing the function. And then I have to continue by applying natural log to both sides. Then I have to bring in 1 over x squared. Then I apply, in step 4, I apply the limit to both sides. As x approaches 0 from the right equals limit as x approaches 0 from the right from natural log of cosine x over x squared. Now I have to have the new assessment. What is the new assessment for this one? Anyone? What do you think?
0.
0 over 0. Awesome. That's why I show the 0 over 0. That's why I'm applying L'Hopital's rule. Otherwise, I'm not allowed to. Do not drop the limit operator, please. You are not applying it at this stage. You cannot drop it. When we differentiate this, we get 1 over cosine x times the inner function prime, which is negative sine x, over 2x. Always look and see what you have. And notice that this is negative tangent x over 2x. Again, the assessment is 0 over 0. Again, I'm happy because I can apply L'Hopital's rule, but I show the assessment. I'm not continuing just because. I'm continuing applying the L'Hopital's rule because I can. So I have limit as x approaches 0 from the right from negative secant squared x over 2. Now I can stop because I apply the limit. This is 1, so the answer is -1/2. In step 5, I copy the beginning of step 4 and the end of step 4, and I will be swapping the operators. So I can write, if you want, natural log of limit as x approaches 0 from the right, from y. Now you can replace it if you want. Equals -1/2. And this is the final step. What is the limit as x approaches 0 from the right, from cosine x to 1 over x squared?
E to the -1/2. Or
E, very good, to -1/2, or 1 over the square root of e. Very good. So back to this list, what would you like to work on?
I had a question
Yes, I'm ready.
from
Yes.
4.4 from WebAssign.
Yes, any problem, any question, I'm ready.
So this would be number 8 from 4.4, and it reads, find the limit as x approaches 0 of e to the 5th x minus 1 minus 5x, all that over x squared.
So can you look
Oh
and
no,
see?
the minus 1, so e to the 5x is one term, and then minus 1 is another term. I'm sorry.
No worries, no worries. You didn't say anything wrong. I just assumed that, yeah, we'll take care of it right now. So let me read this back to you just to make sure. E to the 5th, I'm sorry, e to 5x, and then next to it, -1 minus 5x over x squared. Limit as x approaches 0 from either side. Is that correct?
Yes.
Perfect.
Thank you.
Thank you. So now, first of all, the initial assessment. E to 0 is 1. 1 minus 1 is 0. 5 times 0 is 0. 0 in the denominator. Lovely. I cannot think or hope for more. So this is limit as x approaches 0. I differentiate e to 5x, and I have 5e to 5x. I differentiate this, I get 0. I differentiate this, I get -5. I differentiate this, I get 2x. I try again. E to 0 is 1. 5 minus 5 is 0. And 0 again. Lovely. Limit as x approaches 0. 25. E to 5x. Differentiate this, I get 0. Differentiate this, I get 2. Now I apply the limit operator. E to 5x is 1. I'm sorry. E to 0 is 1, so I get 25 over 2.
can you go back to the 5e to 5x? No. Yeah, when you evaluated that for 0 over 0.
Yes. E to 5 times 0. E to 0 is 1. 5 minus 5.
Right. Sorry, that was it. Bad math.
That's okay. Good. Perfect question. Anything else? Okay, so let's go back then.
Another.
Yes, I'm ready.
Sorry, another one from 4.4.
Yes, I'm ready.
Number 11. Find the limit. Use L'Hopital's rule. Limit as x approaches 1.
You said 1?
Yes, as 1. The first term is 5x divided by x minus 1 minus 5 over natural log x.
Perfect. This is one of the examples in which I cannot initially say anything. So I have to find the least common denominator and then analyze the situation. So this is one type. The other one is with the absolute value. I have to simplify the function without absolute value first. This is another example. At this point, I don't know what this is, but I will, because I will find the limit. I will find the least common denominator. It has to be the product of these two. This needs to be multiplied by natural log x, and this needs to be multiplied by x minus 1. So 5x natural log x minus 5x, but plus 5. Now I can make an assessment. X approaches 1, this is 0. This is negative 5 plus 5. This is 0, this is 0. So you cannot, at this stage, you cannot make an assessment, or the initial assessment has to wait. Okay, at this point, lovely, because I can apply L'Hopital's rule. Do not drop the limit operator, please. This, I have to be careful because it's a product. The first function prime is 5 plus 5x times 1 over x is just 5. Minus 5x prime is just minus 5, and this is 0. Now again, I have a product. The first function prime is 1 plus the first function times the second one prime. Of course, these two go away. I have limit as x approaches 1 from 5 natural log x. Natural log x, but 1 over x times x will be positive 1, but minus 1 times 1 over x. Now I make the assessment again. I determine what this is. 0 again. 0 plus 1 minus 1, 0. Lovely. So limit as x approaches 1. Numerator is 5 over x. Denominator is 1 over x. And we talked about this a long time ago and many times. 1 over x prime is negative 1 over x squared times negative 1 plus 1 over x squared. Okay. Assessment again. Oh, 5 over 1. Fine. 1 plus 1. Done. Any questions? Any questions? Okay, back to our list.
Did we go over 6 is the Weber sign at 4.3?
Yes. 6 in 4.3. Can you?
You might have to look it up.
Okay, then. Sure. Allow me 1 second to go back. You said in 4.3. 4.3. Okay. View 4.3. View in 4.3. And you said number 6. Consider the equation below. Find the interval of which f is increasing. Okay. So is this the one?
Yes.
Okay, perfect. 5x plus e to negative x. So first they want increasing, decreasing, then the max min, inflection point. That's fine. Okay. Perfect. The function is defined everywhere. So I will determine the first derivative. So f prime is 5e to 5x minus e to negative x. Okay. F prime of x being 0, undefined will never be, because let me rewrite it one more time here. I meant it minus. So e to the x can never be negative, so can never be, of course, negative, but it cannot be 0. So undefined is not the case. So we may be able to find solutions here, but f prime of x being undefined, no. Okay. So I'll try to solve this equation. So we have 5e to 5x minus 1 over e to the x equals 0. I will multiply both sides by e to the x. So I get 5e to 6x, because 5x, copy the base and add the exponents, minus 1 equals 0. Or e to 6x equals 1/5. I apply natural log to both sides, and I get 6x equals natural log of 1/5. Or x equals natural log of 1/5 over 6. I have no idea what that means. So natural log of 0.2, 1 over 5, divided by 6. Gee whiz. Negative 0.27. I'm checking my numbers. Of course, it's negative because of that. So yes, natural log divided by 6. Okay. So this is the only critical number. And now we'll study the sign of the derivative left and right. Okay. So the derivative is also 5e to 6x minus 1 over e to the x. This is always positive. So when I plug in here 0, I get 5 minus 1. So that will be positive and negative. Okay. So back to, allow me to share my screen again for 1 second. So up here, it does not say anything about approximations. So I cannot use negative 0.27 because it will give me a wrong answer. I mean, it will say it's an error. So what I will have to do